Hello, everyone. This session is being recorded. My name is Yelena, and tonight I'm going to introduce you to R and RStudio. So here is the agenda. You're going to learn what is R and RStudio, environment and the interface, how to save your commands in the R script, how to use the variables, how to read data from the CSV file into R data frame properties, data visualizations, and more. So for the purpose of the demonstration, here is a data set that I'm going to use. That the data tracks the employer's job satisfaction, number of months since last evaluation, number of projects the person had been in, how many years with the company, and the goal is to predict if the employer still stayed or left, right? So you've got the department and etc., right? So you've got this information here. So now, what is R and what are R advantages? Well, as you may have heard, R is a language for statistical analysis, right? So, and it works well for your course because it's free and it's an open source. It's also available for different operating systems, whether you're using Mac or whether you're using Windows, right? Excellent data visualizations. Then, very important, the results are reproducible. So you may save your result, you may save your comments in a script, and then to reproduce the result, you just rerun the code. There is an excellent online documentation. It's continuously growing as we speak. New package gets developed, right? It works well in academic environment, which is your case. And you can also use it with databases, right? And it supports parallel processing. However, does R solve every problem? No. First of all, there is no graphical user interface. You need to spend some time to learn it. It's case sensitive. Then it may not solve all the problems that you're trying to solve. In order to install R and RStudio on your PC, you must either have the local admin rights or you need to know what local admin password is, right? And in terms of performance, it's slower than Python or Java. So now, what do you need to install? Two things. You need to install the latest R version, then the latest R version of the RStudio for the desktop, right? So few things to keep in mind. You can, in general, run R without RStudio, but you cannot run RStudio without R. First download R, then download the latest version of RStudio, right? So what is RStudio? What am I talking about? That's an integrated developer environment, right? So that makes it a little bit easier to run your code, and it makes easier to preview the functions in etc., right? And you can also see the commands history, right? But still, even though there are some menus, you want to make sure that all work is reproducible and you do it by writing the code, right? So I'm going to show you different windows. Basically, what's going to happen is when you install it, it's going to look something like this. Here, it's showing you the latest R version that you have installed, right? So that's window, that's called the console window. This is a window where your commands are being echoed, and you can run just commands by typing in here, and it will show the output. It will show any errors or warning messages in this window, right? Like, for example, if I want to know what versions of R I'm running, right, I'm just going to type R version, right? It's going to give me the current version of R. See that that's a result? And at the same time, if I go to this tab, see that that's an environment tab. At the moment, I have nothing because I did not create anything. I did not create any objects. History, that shows the latest command that I ran. So see here, I ran the command to check the version of my R, right? And tutorial is just the package you can install to watch the tutorial, right? So what do you see here? Files, those are the files in the working directory, and we're going to talk about that. Plots, this is where your visualizations are going to show. Packages, all code in R is organized into the grouping, it's into the sets of called packages. So package it's a set of predefined functions, maybe data sets, and sums of the vignettes and the documentation, right? They group together. Next one, this is going to be your friend. That's a help page. So you can basically search for command here, and it will give you the command description, command usage, which parameters the command take, etc. Right? So just know about this. Now, I mentioned earlier that you want the work to be reproducible. So how do you do that? You need to create a file. You're going to go here, file, new file, and what type of file is it? R script, right? Then you're going to save your code here, and you're going to type your code here, and you're going to save the file with extension .r, right? So if I go file, and if I do save as, it's going to save it with .r extension. Notice where is it saving? It's going to attempt to save the file in a working directory. So working directory is a default directory that R is going to look by default, right? So now suppose that I worked on something, I don't remember where I saved it. Here is the trick. You go here, file, and then you go to there is an option here, which is called recent files, right? And here are the files that you had recently opened. So I can open my file here, right? So let's go back. Want to make sure. So I covered different windows, right? Here. Now, what's an R script? You just create a new file. An R script, it contains a sequence of commands. So you may run to reproduce the results to the point where you stopped. Then remember that if you deleted something, there is no undo. The way to recover it is to rerun the code, right? And when you run in the code, the script output will appear in the console window. So let's see here. For you, I wrote the script, and I'm going to give you a copy. After this session, you're going to get the recording, and you're going to get a copy of this code. So now, what is this? See this, the hash mark? This stuff that follows the hash mark, this is called a comment. Comment just tells this, it's a description of what the code does. It's not an executable command, it's just a description. Like for example, here, the command is r.version to show the current version of R. Alternatively, you can run the command version. It's going to return the same, to return the version, right? So it's here. And the way I usually run it, I put the cursor on a line and I click run. I usually run it like this, but everyone does what works for them. There is another command that's going to show you the current session information. Session info command. It's going to show you current session information, right? So here, this I mentioned package. Those are the packages that are in memory at the moment, right? So all of these libraries here, some of them are going to be in memory at the time when you start the RStudio. And remember that there are two types of packages. System library is what is being pre-installed. When you install R and RStudio, system library is pre-installed. User library is what you will install for your assignments. For the first package is rules, right? And you're going to install it to do discretization, and you're going to install it also to do the association rules next week, right? So here, this one is going to show you the current time, right? Notice that everything in R is a vector. So if you look at it over here, do you see this little bracket, one in the brackets? It means that the first element of this vector starts at position 1. right? On this row, the first element starts with position 1. It's a position. Remember, the elements of the vector in R are numbered starting from 1. ls command is going to show you what you currently have in R memory. At the moment, you don't have anything, right? Object is also going to show what you have in memory. I wrote different ways to show the same information because depending on the book you look at, it could be done differently. Now this one, data, is going to return you the available data sets that were pre-installed. See, this is package. There is a package called datasets. The iris package that you're using for the first exercise is located in this package called dataset. It's pre-installed. Here is a whole list of pre-installed datasets. You can see those, right? And they are in this dataset package that is uploaded in memory at the time when you load RStudio. Okay? So close this. Let's go back to our code, right? So now you can use R as a calculator. As you see, I can enter 5 plus 9, run it, and it's going to show me 14. Remember, it's a vector. So number 14 is at position 1 on this line, right? I can just print something, the sentence that I want. But note, I don't have anything in the environment because I didn't assign the value to anything. So what I'm going to do right now, I'm going to create X, and I'm going to assign 3 to an X. So this is assignment operator right here. I'm going to run it again. I'm going to run it. See this right now? I have X in here, and it shows me the length, the size, right, and the value. Oh, but remember this. There are 2 ways to show this here. You can do grid or you can do list. See, this is just a value. The reason I like grid is because when you have bunch of stuff here, a bunch of objects, list, a grid shows you the memory, right? So sometimes if there is something you no longer need, you can remove it. And to remove it, you would just click here and click on the broom, right? And I'll also show you how to do it programmatically. Right, so here I'm going to create, here I'm going to display what X is. So this is a shortcut. You can do print X in parentheses, or you can just do X. This command is going to do 2 things at once. It's going to assign 5 to Y, and it's going to print what Y is. Is this? So you can nest the commands basically. Right, so I have X and Y. RM command is going to remove all objects from my memory. But if it's RM without specified, see here in this case, I specify X, right? I want to remove an object X from my memory right now. What is this? RM command takes a parameter, and I want to list all objects that are in the memory here, and I want to remove them. See this? It takes a list of objects in the memory, and then apply RM command to remove them. Another nice thing is to see options. For example, one option is if output is too long, after how many characters do I cut it off, right? So there are different options for you to look at and play around. Cat command. This command is going to clear the console window, right? That's how to do it programmatically. DevOps at the moment it's not going to run because we don't have any plots. History is going to show you the commands history. I say to show last 5 commands, right? So here. Now we're going to talk a little bit about vectors. As you know, everything in R is a vector, but to create a vector of elements, you can run something called combine commands. So here it combines values 1, 2, 3, 4, 5, and I'm explicitly listing the values. So let's run this. But again, if I go back to my environment, I don't have anything because I did not assign it. Now what I'm going to do, I'm going to assign it to an X, I'm going to assign my vector to an X, and then instead I'm going to use a shortcut. I put 1, column 5. So that's going to take 1 through 5 and assign to an X. So I have X in here, and here it just shows the values, right? And it's an integer, shows values and the size. I switch to the grid view. Here, I can output my X, right? Here, I want to show just the start element of an X. Suppose that I have an X with 1000 elements. I don't want to see all of them. I only want to see the start. Class or type of comment is going to show you the data type, right? str is going to show you the structure. Like, see this? This is a vector and it shows you the structure. Here, if I want to create a list of elements from 1 through 5, then from 8 through 10, in other words, I want to skip 6 and 7. I can do it this way. I can say 1 through 5, comma, 8 through 10. And I'm using combine command and I'm assigning it to y. Output. Well, it may look a little bit simple, but then all of those little pieces are used in more complex commands. Now here, I'll output the elements 3 to 6. So I put it in brackets like this, right? Then here, I can check the data type of y, structure. Now, this here, it will multiply all elements of y by 2. Then we verify, works, right? Another thing you can do in R is you can create sequence. For example, let's create the sequence of 10 elements starting from 1. So in here, I did not say where to start from, right? So it's going to start from 1, and it's going to increment by 1 by default. And I'm going to save it as Z. I'm going to assign it to Z. Then I can preview my Z, right? Oops, here. I preview it. So that's a sequence of 10 elements, right? Now here, I want to specify the start. I want to start with 2. What's going to happen now? So see this? I'm starting with 2, and let's output this. See this? So here, I have from 2 to 10, right? And step still is 1. I can specify by parameter, so I'll just say start at 2, end at 10, right? So this is end at 10 and increment by 2, right? Here we go. So it's a start at, end at, and increment by. R has excellent help system. For example, suppose that I want to read my help page about the bar plot command. How do we do it? Well, you can type the question mark followed by command. So question bar plot is going to do what? It's going to display the help page for bar plot here, right? So it's going to tell you, see here, that's a purpose, what the command does. That's here, it's like when you use this. In here, it also shows you some examples of how you would run commands, the argument that the command takes, right? So you can read all of that, right? And also, there are some examples. These examples are for a pre-installed data set, and you can actually run those and you can play with those examples here, right? And here it shows you in what package this is defined. Bar plot command is defined in a graphic package, right? So that's excellent documentation. You can also display this page just by typing help command and the command name in parentheses. Now, suppose that I don't know how to spell the word bar plot, but I know that it starts with bar. I can run a propose command that's going to list functions that contain the word, that contain bar, right? So in here, then I'm going to find what I need. See this bar plot. See this? Another thing that you can do is you can search online documentation. That's a command. Our site search is going to search online, right? Earlier today, I mentioned that there is working directory concept in R. working directory is a folder where R will attempt to save your file by default. Then when you read the data from the CSV file, that's a location where R will look by default. So for your first exercise, you're working with data that was pre-installed. For your next exercise, the CARS data, you'll be working with the data in CSV file. So what you need to do is you need to read data into R data frame. But before you can read data, you need to set the working directory. Where should R look at to read the file? In my case, I created folder called datasets on my C drive, and I saved the file that we're going to use today in that folder. So now I'm running setwd command to set the working directory. Here, now getwd return what my working directory is, right? So I'm going to run that. It shows that I set the working directory, but remember everything in R is a vector, right? So that's what one means. Here, notice the title bar here shows the working directory you are in right now, right? I can list my files in the working directory. There we go. See this here, this is 5 because this is a 5th element in the output, okay? Now, if I try to read the file and I'm getting error that it does not exist, I can do this check. There is a command called file exists, and it's going to check if you have such a file, right? Now, our next command is we're going to read the file into the data frame, right? So you have a CSV file, and the file contains column headings in the first row. So you have to specify header is true, otherwise R will name columns as column 1, column 2. You want to use the names that are in the file. This is a delimited, right? And this has to do with how it's reading factor columns. All right, so you want to read the data, it will attempt to read the data type. So this will read the data from the CSV file. HR is a data frame, so let's look at it. Let's look at what HR is. So I just read it, right? Here, this is a data frame. Length is a number of columns. See, here is the size, but here I'm going to switch to the list view. Okay, so here, if I expand it, well, this is a non-programmatic way. I'll show you both. If I expand it, see this? You have how many rows are in the data frame, and here is a number of columns. It lists each column here, column name, column data type, right? Then here, there are different data types, numeric, and this is called factor. Factor is when the values and number of values are predefined. For example, here, salary, there are 3 values. In this case, high, low, and medium. So what you see in here is the list of values. Then in here, number 2 means that in the first row, in the first row in the data has the value low. Low is an index 2. There are 3 levels. This is called levels. It's another terminology for these values. Level 1 high, level 2 low, level 3 medium, and here it shows the level, right? So that's how this shows here at the structure, right? So now in here, you may like this command in here. It's gonna view command. It's gonna show you the spreadsheet view of your data. So I'm gonna run this, and it will open data in a spreadsheet view, which is kind of nice. You can sort it, etc. Right? Now, but you can't assume that you have this interface. So another way to do this, to preview data, is to run the head command. By default, head command displays just the first 6 rows. Notice that it wraps, because if all columns do not fit, it's gonna wrap. So I can resize my window, and I can run it again, right, etc. So see, it will still wraps. Okay, now, so here I want to specify how many rows I want to view. So I want to view the first 10, I specify. So the default is 6, but I can specify how many, right? I want to do first 10. Tail is similar, but it's gonna show last 6. Then I specify I want to see last 10. Easy so far, right? Now, I showed you how to see this data frame structure here, but how do we do this programmatically? We're gonna run the command called str. str command returns the structure. You see this? It's gonna return this information here. Just you want to know how to do it programmatically, right? By writing the code. Class, it's gonna return the data type, which is data frame. Here you can just check if it's a data frame, right? There are several ways to display your column names. You can run the command call names, and you can run the column names, right? So you want to know how to do it because sometimes you take this list of column names as an input to another function. Like perhaps you want to display something for all columns in the data frame, right? So you would have to send the list of columns, something like that. Dimensions of the data frame is the number of rows and the number of columns, DIM command. Now, if I want to see only number of rows, well, remember the output of DIM is a vector of 2 elements, right? The first element is the number of rows. So I have 2 options here. I can just show n row, or I can display the first element in the output of DIM command, right? So that's going to give me number of rows. And call command is going to give me the numbers of columns, and the same as length. Then the same as second element of the output the DIM returns. And what am I doing here? I'm taking the list of column names and taking the length of the list of column names. Make sense? So that was the structure. Now we want to look at the summary for the entire data frame. We want to look at the descriptive statistics. I'm going to run the summary command, and I'm just going to use HR, right? It's a data frame where I write the data into. So what do I see in here? I see it for the numeric columns. I get the summary, minimum, fourth quartile, median, mean, third quartile, and maximum. What is this NA? That shows me the number of missing values in a column, and we're going to get to it tonight. Number of missing values. For the categorical columns, the way it shows here is that it's going to show the levels, right? So level, it's a value, and how many rows have that value. Like for example, in the data set, you have 4,140 rows that have department equals sale. It's going to show 6 dominant values, and the remaining values are grouped into category called others. But what if I want to see more than 6 dominant values? There is a way you need to pass the parameter called max sum. Max sum can change how many dominant values I see. For example, here I'm going to run it with max sum equals 9, and see, it's going to show me right now. It's going to show me more, right? It's going to show me more values. See that? I can specify, right, how many values I want to see, right? And the remaining, right, will be grouped into something called others. Another way to show the summary, I'm going to run lapply command, and apply command is going to either specify commands to each column of the data frame. The data frame name is HR. Now the output is different. It just lists all of the departments, not just dominant, all of them, and the number of rows for each department. See, and see this for numeric, the same, the number summary. Here is the number of missing values, and we'll get to it. Suppose that I don't want to see the whole number summary. I want to see just the minimum, and for one column. So what I do here, I specify the data frame name followed by the $sign, and here it's a column name. So I'm gonna run this now. It's gonna show the minimum, the satisfaction level. Range is gonna show you minimum and maximum, right? And this here, you may notice that the number summary does not show standard deviation. You need to run SD command. Unique, it's gonna show you the unique values of the column. See that? So in this case, I specify unique departments. You can do the same thing by typing the levels command, right? So here, I want to display the maximum satisfaction level for department. So that's what I'm doing here. I'm specifying here for department, see? HR department. So let's see. And this using the function called aggregate, right? Maximum is 1. Next thing is the subset. So how do we take the subset of the data frame? Here, you specify the rows that you want to take. And rows numbered starting from 1. So here, I want to take the first 5 rows. After comma, I specify the columns that I want to take. If column list is omitted, it's going to take all. So in this case, it's going to take rows 1 through 5 and all columns. And I'm going to just output. I'm not assigning it to anything. So when I run it, it's just going to show the output here. On the other hand, in here, I'm assigning it to new HR, and it's going to let another data frame in here. See? Because I'm doing assignment. Now, suppose that I want to see first 5 rows and a column at the position 1 through 3. It's possible. So what I'm doing here, this are the rows, and here are the columns, 1 through 3. Run it, right? Now, in here, I want to show, this is another way, I want to show columns 1 through 6. What is names? Names is going to return the list of column names. And from that list of column names, I want to select the first 6 and also first 5 rows, right? This is here, it's differently. This is called combine command. And what I'm doing is I'm taking the columns at the position 1, 4, and 5, and first 5 rows. Instead, here I can specify the column names that I want to take. And here, see if the rows are omitted, it's going to show the entire data set at least 2 columns. Right? So now if I want to see the value of salary in the first 4 rows, how do I do this? I can do this. HR, $sign, summary is the column name. 1 through 4 is going to list the values in the first 4 rows. Here, you can specify the rows which satisfy the certain condition. For example, I want to display all rows where salary is medium. And here, I did not specify which columns I want to see. It means it's going to return all of them, right? It's going to return all columns. Here, I want to say multiple conditions. So this is and. I want to say the department is HR and salary is medium. I did not specify which column, so it's going to show all of them, right? Now, you can easily add a column. To add a new column, you can do this. You can put the data frame name, $sign, and this is going to be new column name. And you assign it to the values that you want. Like in this case, for example, let's say I have here I have the number of years spent in the company. Suppose that I need to know the number of months spent in the company, which is number of years times 12. So what I do is here I specify new column name, and that's a calculation. Now I need to verify. One way to verify, I can run a head command and I can preview the first 6 rows. So this is 36, and that's 3 years. That's how you verify. Now suppose that if I want to delete the column, very easy too. You're gonna set the column to null. You put the data frame, the $, column name, and you're gonna set it to null. Now, if you run the head command, you're gonna see that the column was removed. Next thing is sorting. So why do you sort things? Sometimes I want to see, for example, top 5 scores. Sometimes sorting could be used to eliminate the duplicates. So here I want to sort my data extending by age, and I want to create new data frame called HR sorted. So here I specify the row conditions. I want to take all rows. See here, I want to order all rows by satisfaction level, and I want to select all columns. I didn't specify the columns, right? So now I want to preview the first 10 rows. So here it is, and they're going to be sorted by satisfaction. But you can also sort by descending. To sort by descending, you just put a minus sign. And you can sort by 2 columns as well. See, that's sorting by 2 columns. Then, these are the HR sorted. It's going to override the previous value. See, you can sort by 2 columns or by more than 2, right? Now we're going to talk about the factor columns. Factor have a set of predefined values. We know what values are in advance. Like we saw in the department, we know the values of department in advance, right? So the values are discrete, not continuous, but discrete. But if you notice that there is a column called attrition, and the values are 0 and 1. That tells where employee left or stayed. But the problem is the column it's reading the column as a number. So, and the statistics that it shows the average, but how could an employee live halfway? It does not make sense, right? So for some analysis, we want to convert this column to a factor. So here it is, this is column. This is a factor function. So what I'm doing here, I'm setting the column left to column left converted to the factor. See, this takes the column name as an input, and that factor will convert this to the factor. How do I know? If I run the summary of this, see now it shows me how many employees left, how many stayed. Is factor is going to check if command is a factor. True. Right? For the factor columns, you can display the frequency count. You use table command to show the frequency count. So here, this is for single column. See that? So I know for the salary, I know how many rows, how many employees had high, low, and medium. Here, I can show the proportion for each value, right? Right, so like instead of showing how many, I want to see the percentage. Here, you can do the frequency table for 2 columns. So what is it going to look like? I show in here, it shows the salary. And here, it shows if an employee stayed or left. So for example, this number here, here it shows the number of employees with high salary and attrition value 0. So 1 means left, 0 means stayed. So that is how you show this tabulation. Next thing is the missing values. I mentioned that sometimes the values are omitted, right? And some functions do not work with missing values. Like for example, we had a column called last month since evaluation, and the column has some missing values. What's going to happen right now if I run the min function? Take a look at that. It's not working. So one way to make this function work is to say NA.rm equals true. So this will run it will ignore the missing values. Default is false, but here I want to calculate the min and I want to ignore my missing values, right? How do we know if the data has missing values, and how do we know which rows have a missing value? Well, any command here will return, any is going to return if the data has at least one missing value. Is an A, checks if the value is missing, and it's going to look through the entire data frame. So if there is at least one missing value, it will show us true. See, true, it means that in a data frame, we have at least one value missing. Sum is an A is going to show how many values are missing for each column, right? So we need to know which columns are missing values and how many. So I'm showing this. See that? 2. All right, so here, it's just showing me the number of missing values. So in this case, it's just going to show you the number of missing values, total number. This is the sum, right? Sum is going to show how many values are missing total, not just per column. I know it's 2. Here, I just want to show how many values are missing the value of last evaluation. Let's run this. It's going to be 1. So which row is missing the value for last evaluation? How do I know this? Here, this is the row number 375. See which command is going to return the index of the row, and I'm specifying missing last evaluation. Okay? Now here, I want to display the observation if they're missing a value for at least one column. Complete command returns the complete rows, right? No missing values. This is the negation. So I'm saying here, return all columns, return the rows where at least one value is missing, and I did not specify which column, so I want to do all of them, right? Right, see that? All columns, and it's going to list here. See these 2 rows? Do you see this? I have average monthly hours missing, and then in another row, I have last evaluation here missing a value. You can check how many instances are missing the values per column, right? Next thing is, so how do we deal with missing values? Multiple ways. You can omit the rows that have missing values, or be aware that omitting rows could result in losing valuable data. So sometimes you want to set the missing values to the column average. Sometimes if you have a column where most of the data is missing a value, you want to just remove the column from analysis. In this case, let's say I want to create new HR and I want to omit the rows missing the value, missing at least one value. So what I'm doing here, I'm just doing an omit. I'm creating a new data frame, and it's supposed to be 2 rows less than the original data frame, because we know that we had 2 rows with missing values. So see, that's correct. This is one way you need to verify your work. So you know the total number of rows, you know the number of rows missing at least one value. If you omit those rows, this is the number of rows that should be left, right? So that's a new HR. So handling missing values by replacement. So how do you do this? You want to replace by the column average, but remember, to get the column average, we need to say an ARM equals true. Otherwise, this min function is going to fail. How do you know? See this over here, you're specifying the data frame name, $sign column name, Here, this is the condition. You want to apply this to the rows that missing a value, and you want to set those rows, right? You want to set those rows to the mean of that column, to the column average. And here, this is another example. I can set it to the predefined value. Like for example, if we do not know if average monthly hours are missing, you want to set it to 200. It's just an example. Huh? Or if the column was categorical missing a value, perhaps you can set all missing values to the category called other. Right? So you can do the average, you can set the predefined value, you can remove the rows missing a value, or you can remove the column missing values. If the column is missing values for most of the data, perhaps. Summary here, that will show the summary for this last evaluation column. I just want to show you that NA is gone because we just handled the missing values. Then here, I want to check if there is at least one value missing. See here, I'm listing the list of columns, and I'm listing how many values are missing. None. Right? I took care of it. Packages. What is a package? It's a grouping of code and the data. Right? So you can do the command browse URL. It's going to show you the list of available packages in a CRAN. CRAN is a repository of packages. Library is going to show you the list of packages that you have installed. Library is going to give you the list of installed. So, oops. So library, it's in here. See, it shows it here like that. Those are packages that are installed, but see this and shows you where it's installed. And libraries, those are that were pre-installed with R. And here are the user defined that I installed. They're gonna be in this folder, right? If package is installed, it does not mean that it's necessarily available for use. To make the package available, you need to load it in memory. But if you want to check which packages are currently loaded in memory, you're just going to run the search command. So search command tells you which packages are loaded in memory, right? So those are the packages loaded in memory. And remember, we talked about the data set. So it contains iris data. And here it's going to show you locations where the packages are saved. You should see two directories, one for pre-installed, one for yours. To install the package, you're going to run install packages command. I already ran it, but this is a command to install packages. And you specify the package name. This package you're going to use for discretization and to run association rules next week. Library, this loads package in memory. Remember, the package needs to be loaded in memory. So you can use library command or you can use require command. So see this loading? You may notice some of the messages here, but these messages are informative. Even though they're in red, it does not say an error. It just shows you that it's loading package called matrix. So it means that a rules package that I want to load, it depends. There are some dependencies on package matrix, and the package needs to be loaded in memory. Here it's just saying that the package called a rules has the same methods that the package base, which was preloaded at the time when you started R. So if in this case, the methods abbreviate and write in a rules package is going to mask the method with the same name in the base package. Right? So makes sense, right? Right. So here, so you may have a method with the same name in multiple packages. And I'll show you how to handle it. But see, this is how to load, right? This is how to load the package in memory. In here, this is, I just want to show the documentation. If I want to show the documentation, So I just put help. See, this will open the documentation page. This is the documentation for the rules. I'm gonna put it like this in a window, source window. Let's close it out. VNet is gonna show the examples if they're available. Some packages have them, some packages don't. And this one is just gonna show the web documentation. Update packages is gonna update the packages you have to the most recent version. You can specify the specific package you want to update. Detach command is gonna remove package from the detach is gonna remove package from the memory. And remove is gonna delete the package. Right? But if you're using the function in a package, right? One way to know that to solve the if you have two packages loaded in memory with the same function, you would qualify the function name with the package name. That's another way, right? So here, this will just permanently remove the package. That will delete. If it's removed permanently, when I go to packages page, I'm no longer going to see it. If I removed it from memory, it will still be listed here, but you're not going to see the check mark next to it. Right? So now we're going to look at the data visualization. I said powerful data visualization, but I never talked about it. Remember the histogram. The histogram shows you the frequency bin. We're going to use it for numeric columns to show the frequency. So for example, I want to show the histogram for average monthly hours, and I'm going to run it without parameters. So here it comes. This is my histogram, right? See this? X-axis, Y-axis, bins. I did not specify how many bins I want. I did not specify the title. I didn't specify the color. I didn't specify anything. Here, well, what you want to do is do you remember the help command? I can type the help command and I can type the histogram. So play around. You are asked, in fact, to play around because there is a quiz question about how to display the title. Right? If I want to show the histogram and I want to show the title, how do I do that? So you may want to have R open when you take the quiz because you might get that question. Never know. And so here, what I'm doing here, well, I recommend you that you read this. What does it each one do? And play around. So here, I want to show the number of bins. It will aim to show is 20 bins. So see, I changed that. I want to show the border blue. I can do that. Can we? Here, I want to show the color of the bar blue. I can do that. I can use multiple parameters in here. So here, I specify I want columns in blue. I want to show the density, I want to specify, the density of these lines and the angle, specify the breaks, and this will show I'm setting the title of the x-axis. Right? You can do this. Here, the bar plot is going to show the frequency. Bar plot takes the frequency as an input. So for example, there are two ways to do it. I can create the frequency table here for the salary, store it. So that's a frequency table. And I can take, bar plot can take this frequency table as an input. And I'm just going to plot my bar plot. So this is a bar plot, right? So it's taking the frequency table. Ultimately, I could just substitute. I can take this command and put it here. I can do that too. Now, if I want to plot my bar plot, but I want it to be sorted, How do I do this? I just do the scissors bar plot, and in here I specify the order. See, I specify the order. In here, another way I want to specify, I want to make my bar plot horizontal, so that, and you can specify, you can use multiple commands in here. You may use multiple parameters in here, right? So let's see what's gonna happen. Oh, that command in here, it's just gonna show the horizontal plot, and it's gonna be ordered ascending. But I may have deleted the plot. Not sure what happened. Oh, I may have deleted the plot, bar plot. Sorry. All right, so I'll put just bar plot. That's it. Oh, Jesus, now, okay, run. There we go. Now, okay, anyways, a pie chart is going to show the categorical column distribution, but please remember this. For the pie chart, it does not work well when the column has many values. It just gets cluttered. This is very useful to see the proportion, right? And it's especially it's useful when you have only a few values. But when you have many values, you probably want to see the bar plot. Most of you remember about the box plot. There is a command called box plot here for numeric columns. Then there is a generic function called plot. It's going to do what it's going to do. It's going to pick up based on your data type, right? You see here. Then I want to do the line. And here, it's just going to show the categorical columns and etc. Right? All right, so I'm going to go back to slides to make sure I showed you everything. Slides are basically the notes. Remember, we talked about the console window, right? We talked about the environment, how to see it, how many rows and number of columns. Those are the commands. I just put the screenshots. So this is for you. I'm going to give you the slides. It's an explanation. So you have that, and that you're going to have the data, and you're going to have the code, so that you can follow along and run the examples. Right? We talked about the help files. Another way is that in the help panel, you may type the command that you want to search for. That's another way. Or you can run the question mark and the command, right? And you've got the command history. Another thing that I did not show is, Jesus, if you use up and down arrow on keyboard, you are scrolling through the latest command history. Another thing that you can do here is I can go to the history. I can select my command in here, and then here to console, it's going to copy the console command to console window, and I can just click run. This is how you rerun the command from the history. However, please save all work in the script. Because, for example, suppose that I deleted the column from data frame by accident. What am I going to do? Well, very easy fix. You're just going to rerun the code to restore the data frame. That's it. There is no undo, but you can rerun the code to restore. Right? Very easy. You just rerun the code. And it's easy because you save the work in a file to make it reproducible. Right? So we talked about working directory. Remember, that's another way to set the working directory in the options. That's another way to change the default. We talked about the previewing data. We can preview the data as a grid, right? View command. And very important, remember that R is case sensitive. Right? So sometimes, right, if you get in an error, you want to check capitalization. Not just data frame structure. str comment returns structure. Summary is the summary. And this is the structure. Remember the difference? The data frame properties, we talked about that. We talked about taking the subsets, right? We talked about how to check for missing values. So when, and we talked about deleting the column. So when would you delete the column? Sometimes the column is a unique identifier, so they do not add values to analysis, especially when you get to neural network. It could slow down the method. You want to remove columns that track sensitive data, let's call the PII, for example, social security names that should be removed from analysis. If the value is missing for most of the data, you want to remove it. If you have a column that has a value for the same instances, like for example, suppose that I have a column called country and all values are US, you want to remove the column from analysis to save the storage space. Right? So remove what you don't use from the data frame to save the storage. Those are just the descriptive statistics. We talked about that, right? We talked about the sorting. Sorting useful to identify the duplicates. And suppose that I want to see perhaps top 5, top 10, right? We talked about the factor columns, what you can do with them. We talked about missing values. This is an important topic, missing values, and how you handle them before running specific methods. Not all methods handle missing values. We talked about packages. Your first package is going to be a rules, and you will need to install because that's a first user library package, right? Then those are some additional useful commands for packages. Where are they installed? VNet, I like it because some packages show examples. Like when you get to the decision tree topic, one of the packages, it shows the examples on how to run the commands. This is just a data visualization. What I did for you is I wrote the summary on when you use each visualization type. Remember, histogram does not show the actual values. It just shows the frequencies. This may not work well for data sets comparison. So just remember this. Pie chart, you can edit this, you can show percentages. But remember that if the number of slices goes up, the plot could become hard to read. Those are just another data type, generic XY plotting. Did that? How do we exit RStudio? We type the Q command to exit or select quit session from the menu. Here are the two files. R history is a history of commands that you ran, and R data is a workspace image. So you are working on workspace is a collection of objects that you loaded during the session. You can save the workspace, right? So when you start the new session, the workspace objects will be read from R data file. And the commands history will be there for you unless you delete it. Then there is a nice web page that offers free self-paced cognitive. The web page is called Cognitive Class. So that's something for you at your leisure after the class is over. If you want to learn more, there is some coursework, free self-paced that you can take. Well, but this one, hold on to it. This is data 650 topic using RV's database. So hold on to that. All right. Then there are a couple groups on LinkedIn that I'm a member of. And if you're interested in learning more, I would strongly suggest that you join. Well, it's up to you, but I'm a member. Then there are some documentations. I had to list some references, right? So I just listed some. Now it's your turn. Please ask me questions. Anyone? I like when students ask questions. You may remember me from your earlier course. Anything you want to ask me while I'm still here? Anything that... So you remember that you have to do 2 exercises? Then you may want to keep the output next to you as you're taking a quiz, because there are some questions on what commands return for those exercises. The way it works is there is a bank of questions, and the questions are pulled randomly from the bank. All right? So, most welcome. So, basically, when you retake the quiz, you might get some questions could be different, and order of answer choices could be different also. So, when your classmate takes the test, direct question 1 may not be the same as no question 1, and you get 3 attempts. So, no worries. Just take it and learn from it, right? Anything else that you want me to answer? No? Well, and the thing is, you just need to practice, take your time, start early, right? And very important is to read documentation. That's going to help you a lot, right? So, well, if there are no questions, I'm going to end the session. I'm going to stop the recording, and I wish you all successful semester. You're going to get the copy of this slides, data set, and a code, and you're going to get the recording. All right? I wish everyone good luck. See you soon.
Thank you.
Most welcome.
Thank
Oh.
you.
Most welcome. All right, so I'm going to stop the recording.